show that fx equals to x square is uniformly continuous on closed interval minus 2 comma 2, but does not uniform continuous on R. That is, it is x square is the function which is uniform continuous on the closed interval. It is any type of minus 1 comma 1, minus 2 comma 2, minus a comma b, but it is not uniformly continuous on whole R. Now let us prove it. Mod of x1, firstly take mod of x1 is less than equals to 2, mod of x2 is less than equals to 2, right? Take f of x1 minus f of x2. Put the values of this x1 square minus x2 square. This gives x1 minus x2, x1 plus x2. Taking mod of f of x1 minus f of x2, which is the definition of uniform continuity, which is equals to x1 minus x2, x1 plus x2, which is less than equals to mod of x1 minus x2, mod of x1 plus x2. And by triangle inequality, this gives this, and the value of this is 2 plus 2, which is 4, mod of x1 minus x2, which is less than 2 epsilon. Now, if we consider mod of x1 minus x2 is less than 2 epsilon by 4, taking delta is equals to epsilon by 4. Then given epsilon is greater than to 0, there exists delta is greater than to 0 such that mod of x1 minus x2 is less than to delta. This gives that because delta is dependent on epsilon, this gives that f is uniformly continuous in closed interval minus 2 comma 2. It is uniform continuous on any interval a comma b, right? Now suppose we have to prove that f is not uniformly continuous on R. R is equals to minus infinity to infinity. Let us take an is equals to root n plus 2 epsilon minus root n. After reciprocating in this form, and root n plus 2 epsilon plus root n. After taking the conjugate of this gives this 2 epsilon upon root n plus 2 epsilon plus root n. Taking n tending to infinity, this gives an is converging to 0. Now, why we take it? Because we have taken it, we have to prove that this is not uniformly continuous on R. So m positive. M goes to infinity, then it is infinity. M goes to minus infinity and minus infinity, right? So f of x1 minus f of x2 mod of x1 minus square minus x2 square. This gives m plus 2 epsilon minus m epsilon m. This is cancelled out because 2 epsilon, which is greater than 2 epsilon. So mod of fx1 minus fx2 is greater than 2 epsilon. This contradicts the uniform continuity definition. So fx is not uniform continuous.